Hi, this is Mrs. LaBarbara. This is Physics Chapter 12, Sound and Light, Video 3. Today's topic is ray diagram and reflection. The objectives are: no reflection occurs when a wave encounters a new medium. No ray diagrams are used to indicate directions of waves' travel. No ray diagram vocabularies. Know the law of reflection. Understand the difference between diffuse and regular reflection. Be able to sketch or select diagrams in which reflection is occurring. Be able to measure the angle of incidence or reflection on in a diagram. Ray diagram. As a wave travels in a medium, it is not possible to see individual wave fronts in a light wave. So we use ray diagram to indicate the direction of the wave's travel. As you can see, the incident wave coming toward the surface. These are the wave fronts is moving in, and here are reflected wave. So we don't see that. We don't see wave fronts. So we use an arrow that draws perpendicular to the wave fronts to indicate the incident ray. That's the direction the wave is traveling. The ray diagram only shows the direction, not actual waves. This is just showing this is the wave direction, the wave coming into the surface, and this is the way the wave reflected from the surface. Let's see the wave diagram vocabularies or light ray vocabularies. So here is the wave that's called the incident ray. The incident ray is the ray originated in a medium and approaching the boundary. Here is reflected ray. Reflected ray is the one that's rebound from the boundary. The other part is when it goes in. Remember, when a wave comes to the surface, two things happens. When some is reflected, some is transmitted. So some of the transmitted is called a refracted ray. So refracted ray is that resulted from the incident entering a second medium. Reflected is original bouncing back. Refracted is going into the medium. At a point of incidence where the ray strikes the mirror, a line can be drawn perpendicular to the surface of the boundary. This line is called the line of normal. This line, normal line, is the perpendicular to the surface. It's just a reminder. Remember, we learned a normal force. Normal force is the force that's perpendicular to the surface. That's what a normal means, perpendicular to the surface. So normal line is a line that's perpendicular to the surface. Normal force is a force perpendicular to the surface. Now there are other vocabularies. One is angle of incidence. This is the angle between the incident ray and the line of normal. So this line of normal is very, very important because all the angles we measure are from the line of normal. So I is a line of the normal. That's the incident ray. The angle between incident ray and the normal, that's called the incident angle. The angle of reflected angle or angle of reflection is between reflected ray and the normal. And the other angle is angle of refraction. We use theta r. That is the angle between the refracted ray and the line of normal, right over here. So there are two medium. The medium one is air in this case, the other medium is glass. So there's incident ray, reflected ray, and refracted ray. And this line of normal is very, very important because all the angles are measured from the normal. The law of reflection states that when the light changes mediums, part of light will reflect. And reflected light, the angle of incidence always equals to the angle of reflection. Theta I equals to theta I prime. So, or theta r in this case, r is angle of reflection. So once the normal to the surface at a point of incidence is drawn, the angle of incidence can be determined. So we basically use a protractor to measure it. The light ray will then reflect according to the law of reflection. The law of reflection is always observed, regardless the orientation of the surface. Take a look at all different orientations of surface. The angle of incidence always equals to angle of reflection. Let's take a look at this example. The diagram above shows two rays of light striking a plane mirror. which diagram below represent the reflected rays. So here is A comes in, A will reflect it from this point right over here. So first of all, only 3, 4 shows reflected ray, and A is from the right point, and so is B. So the answer is number 4. Another example, so the diagram represents a light ray being reflected from a plane mirror. Plane means flat, right? The angle between the incident ray and reflected ray is 70 degrees. What is the angle of incidence for this ray? Remember, angle of incidence is measured between the incident ray and the line of normal. So that's first, we need to draw the line of normal. So what is the angle? If the whole thing is 70 degrees, what is half of 70 degrees? So the answer is 35 degrees. Another example, identify which angle is the angle of incidence and which angle is the angle of reflection. The angle of incidence is the angle between the incident ray and the line of normal, so the angle B. The reflected angle is the angle of incidence, the angle of reflection and the normal, so the answer is C. Another example, 2 plane mirrors are positioned perpendicular to each other. As shown, the ray of monochromatic red light is incident on mirror 1 at angle 55 degrees. This ray is reflected from mirror 1 and then strike mirror 2. So what is the angle of reflection from mirror 1? So angle of reflection equals the angle of incidence. Angle of incidence is 55, angle of reflection has to be 55 degrees. Now, as this ray strikes mirror 2, what is the angle of incidence? To find that, we have to draw the line of normal. Let's find this angle. We know this is 55, this is 90, so the other angle has to be 35 degrees. So this 3 add together equals to 180 degrees, or 35 plus 50 has to be 90 degrees. So the angle of reflection should be equal to angle of incidence. As a matter of fact, you can draw the ray, and over here should be 35 degrees. Okay, 2 types of reflections. One is specular, the other one is diffuse. Specular has another name, is smooth. Diffuse is scattered. So specular reflection is reflection of smooth surfaces such as mirrors or a calm body of water. Usually you can see an image or a lot of glare. Diffuse reflection is the reflection of a rough surface such as clothing, paper, or asphalt roadways. So anything that you can see without trouble, usually because of diffuse reflection. So the light reflects from all angles into your vision. So each individual ray, however, doesn't matter what type of reflection, each individual ray obeys the law of reflection. Here is a diagram for specular reflection. So all the lights are reflected into one angle only. The other one is diffuse reflection. Because the surface is rough, so the light hit the surface can be reflected in all different directions. Why does a rough surface diffuse a light beam? We just talked about because light is rough, right? For each type of reflection, each individual rays follow the law of reflection. However, the roughness of the material means that each individual ray meets a surface which has a different orientation. The normal line at a point of incidence is different for different rays. Subsequently, when the individual ray reflects off the rough surface according to the law of reflection, they scatter in different directions. The result is that the rays of light are incident upon the surface in a concentrated bundle, but are diffused upon reflection. So sometimes we want a diffuse reflection. So this way, say if you are here, you can still see the object. If you are here, you can see it. If your eyes over here, you can see. It doesn't matter where you are, you can see the same object. That's the opposite of, let's see, specular reflection. For specular reflection, you can only see the surface if you are in this position. If, say, you are here, you cannot see it because the light will not reach into your eye. Let's take a look at this example. Identify whether the following phenomena are attributable to diffuse reflection, DR, or regular reflection, RR. Regular is smooth reflection. or specular reflection. So the image of a mountain can be clearly seen in the calm water of the lake. So if you can see an image, it's regular reflection. A lacquered tabletop produces a glare of lamp bulb in the overhead light. So when you have a lot of glare, that's very smooth. Regular reflection. Water is sprayed onto a sheet of paper. A laser beam is directed toward the paper and reflected and produce the red dot. That red dot is the image of the laser. So that is also regular reflection. Last one, light from overhead strikes your body and reflects toward all your classmates' eyes. So since this indicates the reflection is in all directions, so this is diffuse reflection. Okay, image formation in plane mirrors. So image can only be formed for regular reflection or specular reflection. So when light gives off from an object, reaches the mirror and reflects off the mirror according to the law of reflection, an image is formed. So each one of these rays of light can be extended backward behind the mirror where they will intersect at a point. Extended back means there is no light behind the mirror. We just pretend we can extend it back. It's a imagine lines behind the mirror. So any person who is positioned along the line of this reflected ray can sight along the line and view the image. This is how you see yourself every morning if you look into the mirror. So here's an object to have a bunch of rays reflected from mirror. Each reflection can be kind of extended back. So if you here, it looks like light is coming from here, the image location. Take a look again. So different rays coming hit the mirror. Each line has a reflection according to the law of reflection. If you are here, your eyes here, looks like the light is coming from the back of the mirror, right over here. That's where the image is. So you can figure out where the image, right? So if you have an object here, you know the image has to be with the same distance behind the mirror, right? Symmetrical. Because if you're standing in front of it, seems like there is light coming behind the mirror, even though there is no actual light behind there. Just seems like it. Let's see images of characteristics in a plane mirror. So these are all images. You see yourself, your face, your virtual image. Why do we call it virtual? Virtual because the light is not real. There is no real light behind the mirror. That's why we call it virtual image. So you see yourself the same size. So if your eyes are on the top, your eyes are on the top in the mirror also. So everything is symmetrical. But however, if you raise your right hand, your image will raise left hand. So it's backward reversal. Also, the distance between the object and the image are the same from the mirror. One is in front. If you're in front of 50 centimeters, your image is in the back 50 centimeters. It's the same size, same orientation, but left and right have reversed. Another thing you should know, your image is virtual because there is no real light behind the mirror. These lights are not real. So you probably have seen this. So if you are driving, behind you is ambulance, and you see, if you look at ambulance, see the letters are backward. This is because for the people is driving in front of ambulance. So you can see the mirror right in front, on the dashboard over there, you will see the ambulance, so you can stay away. So here are the characteristics of the image formed by plane mirror. Have to be the same size, have to be the same distance, have the same orientation, means top is top, bottom is bottom. But it is inverted laterally, means left, right, reversed. And another thing is image is virtual, so no actual light meet at image location. Virtual image cannot be captured on the screen. So if you put a piece of paper or a screen behind the mirror, there's nothing on there. It's unlike when you go to see a movie, you actually see the image. That image is real image because the light actually reaches onto the screen, but there is no light behind the mirror. So that's called a virtual image. Okay, what portion of the mirror is required? So the ray diagram can be used to determine what portion of the mirror must be used in order to view the image. As you can see, this is what you have to see: the top of your head and the bottom of your feet. So you basically use half the mirror, right? In order to view his image, the man, in this case, the woman, looks as low as her feet and as high as her head. So man only, or the woman only, needs portion of the mirror extended. And this portion of the mirror is about half of your height. So reflection of light and the color of the object. Have you ever wondered why the color is what it is? It is, you probably think the color is within the object itself, which is not true. The color you see is the color that is reflected. So you have an orange shirt because your shirt absorbs all the other colors except orange. Like, why is the ocean blue? Because the ocean absorbs all the colors, all the red, yellow, green colors in the rainbow, and only reflect blue. That's why it is blue color. That's it for today. Thanks for watching.